So our presentation was joined with Gergely is some outcome of a GreenDIGIT project. And we were working 15 months. And initial that I will, next will be session 2 tutorials. And in this tutorial, my part will be like general regulations. I will explain how we came to the start in the project and how we started realizing how complex area of environmental sustainability to make it compliance, to make it suitable for developers and for operators. And now in this session, we will explain which kind of technical solutions we decided to develop, to which state we develop this, and to what we can propose to wider community. Because as I told, maybe some kind of other places that we need to talk that sustainability aspect is very wide. So sometimes I call this overloaded. If you go on the street and ask people, are you doing sustainability? 70% of people will tell, yes, I'm doing sustainability because I'm using this food, I'm using this energy and so on. But we are focused on research infrastructure, digital infrastructure sustainability. And this was created as complexity of making all this kind of issue, how to develop the common integration component of this development. We came to the, we came to the first item, shared responsibility model, and started talking to other people. And people saying, yes, we need to understand what can be done by provider, what can be done by researcher, and so on. And after that, we came to the architecture definition, the item number 3, and took into account that each infrastructure or each project, it actually exists in a specific life cycle stages. Somebody is designing, somebody is developing, somebody is operating, somebody already terminated. So this was also important aspect of what the GreenDIGIT was developing and analyzing and researching. And metrics and monitoring, this is, I would say, the biggest outcome of technical development for now from the project. Because this will create a basis for all infrastructures to document their metrics, to make a common presentation. Somebody has already something, but looking at this, what we develop in the project, they will simply say, oh, this I need to address more. And we have a template from the GreenDIGIT project that everybody can follow. And I will go for the, how we started the project and how we made the proposal. So we identified that there are 3 aspects of environmental sustainability. First is energy efficiency. How much we consume energy, by which reason, either workflow or computers or virtual machines and so on. So here we came to the conclusion that we need to develop architecture, develop design principles, and also produce recommendation. This item number 1. Decarbonization of digital infrastructure. Infrastructure exists and operates, and any service operates for years, months. But during this, they consume energy, and in sense of environmental aspect, policy or regulations, we need to transform it to the so-called integrating carbon impact, CO2 impact, and also water and something like else. Which is if you attend the first tutorial about different kinds of regulation, you will see how much it needs to be taken into operational stage in operation. And reducing environmental impact. This is already not operation. It started from which kind of equipment you took, where you trash with your equipment, and if you run not digital infrastructure, for example, biochemistry or bioinformatics, you will need to work with medical components. And this is also included into European policy, how you can regulate this. And next, so we came to the understanding that we need to develop architecture. Why architecture? Because architecture provides a way of coordinate different group of developers, operators, users, and even managers for developing their policy and planning, applying for funding. And say architecture, you see, this is different group of target users for architecture. So when we develop architecture, we actually understood that this is complex document. I can show you even our deliverable, they're very thick, but it is targeted for different groups of users and developers. And also, because we are linked to the so-called regulation standard, architecture is the foundation of all policies, regulation, and especially standards. So this is important. So we came to the architecture developments. Here I will not stay long time on this slide because what architecture design principles we use in a GreenDIGIT that we make it horizontal, vertical, very consistent and linked. We also oriented on the so-called continuum from IoT sensors to the edge, to cloud, and to workflow and researcher. And we came to the two components, two major concepts in our architecture. Shared responsibility model, I will show you next slide. And next is a sustainability by design architecture. And how it is defined. So in my professional experience and our people who participate in the project, many years, many people were talking about by design. So based on our experience of group experience, we will come to more conceptual approach how to address, say, something by design. And you will see in the next slides. So shared responsibility. Interesting that we proposed this idea already in May last year, almost a year ago. First, diagram was very simple. But then we started talking to people. People started saying, yes, this is something what we need to know, but make us technical definition of this concept, shared responsibility. This diagram is already the result of, say, April, I would say. So we included some kind of addressing, answering questions, different questions for the different roles. And in May, I discovered that cloud providers, both Azure and Amazon, having also shared responsibility model. I talked to them. We have even joint meeting with them. But then they realized that our concept of responsibility means responsibility of provider, a responsibility of user or researcher. They completely removed their responsibility model from their major advertisement because cloud providers only want responsibility of them. If they try to put responsibility on users, all users will disappear. You understand? But we are in different communities. So we need to define this kind of this is what providers, this is what infrastructure, and this is what research and project and local infrastructure need to manage. How to manage, the flow, how to optimize it, how to connect metrics. And next step is a shared responsibility model. So this is just transitional slide. How it looks like. So we came from the general model and to the so-called five pillars architecture. And 5 pillars architecture includes three main components. First is architecture for research infrastructure that contains typical layers that already define many projects. Many projects that you participated, they also define architecture, grid, resources, platform, scientific workflow, research tools, and final top researchers who need to work with their tools. And 5 pillars that we defined is layered architecture, so shown on the left, software and scientific applications with the blue, and pillars related to life-cycle-oriented for infrastructure. Pillar 4, interoperable common information model. If you want to integrate something in a scale of our research infrastructures that we exist and which are based on EGI infrastructure. So we need to make so-called federation. We need to have a common metric. Something what is already implemented in this architecture is a federated identity management. It also has a common metadata and common information model for user attributes. So we needed to extend this idea to the, say, infrastructure of metrics and optimization. And finally, we cannot, if we work for EGI, S3, if we work for EOS, we cannot avoid data management. And this is one of the big part of the GreenDIGIT project, data management infrastructure. But data management infrastructure surely use a common data format, standard registration, and so on. And this is how it happens. Here, I would say this slide shows 5 pillars. We follow technical and green arrows where we already mostly defined them, and some is okay, orange or yellow is something that we need still to work to the end of the project to make this, say, software fully designed, energy efficient, also data management infrastructure. And I added one more slide. I will not stop on this detailed. Added one more slide is related to everybody knows what is S3. Oh, if you're working for infrastructure here. And S3 defines so-called roadmap 2026. So from 2026, all research infrastructures need to report on the energy efficiency and environment part efficiency. And if you read how they propose to report, technical people will be fully in a denying mood because it's using standards that are not technical. So this is why we may work to the next stage of definition architecture to more pillars like governance and compliance. And we will talk about this at the tutorial. And user awareness. Where is we need to work with users. And research infrastructure lifecycle. Here I want to show only a couple of slides and show you major aspects that we addressed in our project. First, we agreed and identified the common lifecycle stages. According to S3, where we operate for community, concept, design, development, deployment, operation, and termination, not forgetting it. Because according to S3, you need to also be aware how you stop your infrastructure, where you recycle equipment, chemicals, if you are not digital infrastructure, what else? And also data, don't forget it. Delete them, not recoverable. And we came to this kind of more or less definition, what can be done at different stages of research infrastructure life cycle. And then we, according to our project, started analyzing to which compliant frameworks we need to show. This is about activities and roles. We came to this actually careful diagram. But this is very simple diagram. Because then I show this diagram that shows which kind of regulation we need to put life cycle. This is European regulations, and this is standard. For different group of users, developers, and actors, as we call it, they not pay attention to everything. When I show this diagram to a couple of people, they, oh, this is what I need to know. Which standard I need to apply, to which stage. Life cycle analysis. It's a manager. I hear about life cycle analysis, but how I can address in our life cycle. So this is what our goal. How to make integral view to give information for different group of people. And possibly this is reference to different regulations, and this is what S3 will require from us, so-called ESRS. This is two European documents, total in 500 pages, 400 pages, and written in a legal manner. So we actually currently developing this. I will not stop on this very detailed. This is our deliverable for somebody who is interested. 50 pages explaining what are standards, what we need to pay attention. And what is probably I missed one interesting standard. The slide. We are developing tool based on LLM and OpenAI that allows us to take all the standards and get what kind of output is required by developer or manager or operator. And this tool will produce set of requirements or recommendations for this group of people. I think we will finish this by summer, this summer. So if you are interested, keep eye at our announcement. And also to say what we expect as an outcome of our project, there are already 6 deliverables that we produce by August, and will answer questions, impact assessment methodology, what we can do to use self-assessment questionnaire. It will be extremely powerful tool. It's quite a efficient and common approach in many business areas, especially cloud. First policy recommendation. Yes, this would be good advisable. And 3 deliverables from work package, that 5 that oriented on the research tools, virtual research research environment, and federated data management. So this is a total view of the project, and we go to the most, as I told, valuable technical contribution from the project is the metrics infrastructure, and Sergey, it's your floor now. Because next slide is yours. You can just do the scanning this.
Yeah, so just coming back a bit to the life cycle stage and positioning the technical contributions of the project on the life cycle. So here on this slide, it's just showing the bottom left is life cycle to manufacturing and distribution, packaging, and then using the product, and then disposing it, cycle. And then this is just translate that to the S3 life cycle, research infrastructures, including the data centers. That's an element of such a research infrastructure. And it's very similar life cycle with different terminology. Okay, more development, design, preparation, and validation, and then the operation, which is created and then there is the validation. So the technical contribution of the project is fitting into this operation or usage phase, which in case of a digital provider is when I operating the hardware, basically, and through that hardware I provide computing cycles or storage or IoT resources that can be accessed. And so that's where we are positioning the technical contribution of the project. And it's somehow it's what arrow? No, it's okay. So it's at least we need to put it here. But it's not in some regulation.
Yeah, it looks.
Okay. So if you look at if you look at the operation of the distributed research infrastructure, this can be, for example, EGI, a federation of multiple compute centers. Then each compute center, which is represented at the bottom, operates a piece of hardware, which can be an OpenStack cloud, can be some high-throughput compute resources, some storage, whatever it is attached. In other cases, the other research infrastructures in the consortium, for example, Flights has specialized IoT antennas. So big data has, I don't know, supercomputers for data centers connected. So this is at an individual site level, and then at the federation level, multiple of these sites come together and use typically through some workload manager or broker in order to distribute the user requests across those sites. And then the users are defining their experiment or application in some client environment, which can be a science gateway, or can be a notebooks, a Jupyter, or can be any other client site tool. And this infrastructure is quite generic, but it already shows that optimization, if we focus on the operation, which is basically consuming energy for the execution or the operation of services, offers opportunities for optimization. I can optimize resources inside a single site by just sending the jobs to the lowest energy or the most energy efficient hardware, keeping the constraint of the performance. Or even I can shut down certain resources if they are not used and not expected to be used in the foreseeable future. I can optimize at the infrastructure level by sending the new tasks or jobs coming from the user to the most efficient sites. So I can be more intelligent of the site selection. And on the user side, for example, the environment could advise the researcher or the programmer on writing more efficient code. It could also store, for example, the history of previously executed applications, and even sometimes kind of cancel that re-execution and instead take out the historical results from this catalog and save energy basically by cutting down the whole execution of the same thing that has been run in the past. So this is a kind of theoretical model, and where we are focusing now in the next phase of the project is this level, which is being able to collect meaningful metrics about the energy impact of job execution, virtual machine execution, or other types of application execution in the data center, to collect that and to be able to make decisions on that, or to display that to certain users, policymakers, infrastructure managers, so they can better understand where the energy is really used, by which user, by which application across the infrastructure. And to be able to do that, basically we need some kind of metrics infrastructure that can take the usage metrics and related energy metrics from the contributing sites. And in the consortium, we have EGI, slides, libraries, and some data centers. So that's the focus. We are translating those services into metrics, and we are building this metrics infrastructure that's in the middle that can take these metrics, and by aggregating that, it can feed into different display tools, user tools, workload management systems. And here you can study the complexities of this, and it shows the kind of metrics that we expect the sites to report, metrics that we expect other third-party providers to report. For example, the carbon intensity of the energy consumed by a data center at that moment. So we are building this system that will be able to aggregate the data center metrics, the third-party electricity grid-related data, and based on that, calculate what's the total CO2 consumption of a data center or an infrastructure caused by the execution of tasks, which is basically the multiplication of the energy consumed with the CO2 intensity of that energy. And we are working with different types of providers. The initial focus is on the high-throughput compute infrastructure part of EGI, and the next presenter, or Dave Britton, the second presenter after me, will talk specifically about the experiences of the high energy physics community on measuring a similar carbon footprint and energy consumption activity of the physics experiments. And we are looking at also at the cloud infrastructures that are federated in EGI to understand the similar energy consumption of the operation of virtual machine instances there. So I think we finish now the presentation here. I just leave it here as possible discussion topics that we can come back to after the presentations if time permits.
Yes, it's not for me, but it's for Alex. How will share your presentation? It's up down. And now we'll be changed. Okay, I think we should share it.
So next presentation will be